Good evening. Ladi Pupo Aganga here, and the topic that I'll be presenting is on the evolution and applications of special purpose diodes. In the early 1900s, vacuum tube diodes and semiconductor diodes were created. Vacuum tube diodes were more advanced than semiconductor diodes and were used as radio receivers at the beginning of their lifetime. These old diodes, at base level, behaved as the diodes we know today, allowing current to flow in one direction and restricting current flow in the other direction. The first semiconductor, the cat's whisker, was made using galena around 1906 and was not very stable. Therefore, the first semiconductor diode did not find much use and had a short shelf life. From the late 1800s to the early 1900s, scientists Frederick Guthrie, Thomas Edison, and John Ambrose Fleming concluded diodes simply function as a one-way valve, allowing electricity to flow in one direction and blocking current flow in the other direction. With this newfound knowledge, applications were next to come, ranging from switching diodes to turn on and off of circuits to rectification when changing AC to DC. Another application we recently covered in class uses Zener diodes to apply a fixed voltage across the load. To add, I'll be talking about the features, benefits, disadvantages, and applications of Schottky diodes and tunnel diodes. Schottky diodes, also known as hot carrier diodes, have a metal to N junction, as opposed to the P to N semiconductor junction we covered in lecture 3. These diodes specialize in low reverse recovery time, also known as quick switching, and low forward voltage drop of approximately 0.25 volts. From this, the Schottky diodes are great for high frequency applications due to their low forward currents and reverse voltage ratings. They are not well suited for high power applications. Let me say that again. Due to their low forward currents and reverse voltage ratings, they are not well suited for high power applications. Furthermore, the tunnel diode was once the only solid state microwave amplifier available. This factor, combined with its resistance to radiation, contributed to this diode's popularity in the 1960s. These days, you'd be hard pressed trying to find a tunnel diode. They are sometimes used in military applications because of their resistance to radiation and resistance to large temperature changes. Tunnel diodes use resonant tunneling. As a forward bias voltage is applied across the tunnel diode, current reaches a peak, like so. If more voltage is added, the current begins to decrease to a trough, and if more voltage is added, forward current begins to increase again without decreasing. Now, I think I can go over here and insert an image, like maybe drawing. Yeah, drawing. So, okay. Can I just draw like this? No. Okay. Line, arrow. Okay, scribble. Okay, so this is gonna be the graph. We got forward, we got VF here. We've got IF here. As voltage increase, it reaches a peak, and then after you apply more voltage, it reaches a trough. And then you apply even more voltage, and it reaches. It just keeps going. So I later on described this as a hop, and flight. Yeah. Okay. Kind of want to just close this. I don't. All right. Okay. So as explained, tunnel diodes use resonant tunneling. As a forward bias voltage is applied across the tunnel diode, current reaches a peak. If more voltage is added, forward current begins to decrease to a trough. And if more voltage is added, forward current begins to increase again without decreasing again. Simply put, the forward current y-axis and forward voltage x-axis graph looks like a hop followed by flight. What makes tunnel diodes special is their ability to switch between high and low states of conduction even quicker than Schottky diodes, whilst being resistant to large changes in temperature. Tunnel diodes do not make good rectifiers because of their high leakage current when in reverse bias. They are commonly seen in high-frequency oscillator circuits where they allow a DC voltage source to give power to an LC circuit. Thank you for listening.